Hi.
Uh, hi. Can you please, for the panel and the audience, discuss the relationship between the fields of astrophysics, astronomy, and cosmology? Particularly, we want you to deal with some of the similarities and differences between the fields. And also, we want you to discuss how they cohesively work together to move science forward.
Sure. Okay. So the answer is a little bit tangled. The three words. I mean, also I should say the answer to that is kind of slightly subjective. So you're going to kind of get my opinion to a certain extent. Other people might disagree with me. But please bear that in mind.
Noted. Thank you.
The I would say the difference between those three fields is now kind of historical, and that grew up partly because of kind of practical considerations, and also just because of how humanity perceived what the universe was. If you go back, if I would say at least 20, 30 years, but anything from about then and further back than that, then you could make the argument that astronomy, astrophysics, and cosmology were kind of separate things. And to some extent, some places still think that they are. So, like some universities will have a department called the Department of Astronomy and Astrophysics. And it always kind of makes me giggle a little bit because these days there's really no difference. But the way that it used to be thought of was that an astronomer was someone who was very good at operating telescopes, making measurements about what they observed through those telescopes, understanding how the telescope worked, what its limitations were, what it could and could not do, and were really good at taking the raw information that telescope provided and turning it into something that was ready to do science. So, for example, an astronomer might go to a telescope, use a CCD camera, or if you go far enough back, a photographic plate, and take an image of the sky, and then carefully count how many stars or galaxies they saw, and make measurements of how bright those stars or galaxies were, and that would be their work. And that was, even now, that's a very difficult thing to do. But back then, it was even harder because there were very few telescopes, there were fewer telescopes than compared to today. And you had to be really, really good at just understanding every facet about how the telescope worked. Now, typically, that astronomer would not necessarily be such a great physicist, and so this is where the difference first grew up, was that an astrophysicist would then take the results that the astronomer produced and kind of try and attach a physical theory to them. They would, so for it, to give the classic example of this, an astronomer might go and say, here's a really good measurement of how stars in the Milky Way are orbiting the center of the Milky Way. And then an astrophysicist would say, okay, what theory of gravity explains why the stars are orbiting in the Milky Way in the way that they are doing? So the astronomer would kind of get precise measurements of what was happening, and then the astrophysicist would say, okay, why is this happening? How can I fit this into physics theories in general? And then lastly, cosmologists were originally kind of this separate thing, because again, up to maybe a few decades ago, there was this idea that there were these two separate fields. You could study things that were in the universe, and then you could study the universe as a whole. And that those were separate questions. You studied how does a star work, and then you studied as a separate thing, how does the universe work, and why does the universe exist in the way that it does? Those questions used to be thought of as separate, And that's why you had these separate words. Astrophysicists studied, and astronomers studied things in the universe, but cosmologists studied the universe. However, over the last 20, 30 years, I would say things have changed. And so these days, there's no real difference between an astronomer and an astrophysicist. If you go and take images or data from a telescope, you're expected to be able to process those data and make them usable. But then you're also, at least to some extent, expected to kind of say, well, why does this happen? What's going on here physically? Why does this exist? And at the same time, it's been realized that there's a really close connection between the things that are in the universe and what the universe itself is doing. And so I would argue, and bear in mind, some of my colleagues would strongly disagree with me, that there's only one field now, and that field is astrophysics. And then within that field of astrophysics, maybe you specialize more in understanding how a telescope works and what it does and how the instruments work. And if you do that, you might call yourself an astronomer, but you would really be an astrophysicist. And equally, you might go off and do pure theory and try and work out how the universe works. And you might call yourself a cosmologist, but in reality, you're just doing another branch of astrophysics. And so I think for that reason, those three words are kind of just combined really into one word now, but people still use them because of kind of historical convention.
Nice. Thank you for that.
I like it. The fewer nomenclatures, the better, right? Science is hard enough, right? So
right,
without dealing with all the...
You don't want too many labels. You want like one label to describe things. You don't want more than you need. Simplicity is a good way to view it. Yes, absolutely.
Simplicity is key. Absolutely agree.
Totally.
Yeah, that was great. Yeah, that was a great explanation right there.